So guys, I didn't want to be redundant. This has put me in a funny situation, but I'm going to try to break it down. I'm trying to call this a brief introduction to polynomials. Now, if you want to know what polynomials is, check my video out on what are polynomials. And one of the first things they're going to define is a monomial. Okay? So, check that out and then come back and look at this. Okay, I hope you have a better understanding of it. Please, I hope you looked it up. So, a polynomial are basically like variable expressions, right? Variable expressions that are made up of monomials. That's what polynomials are, okay? So this is a polynomial and these are all monomials, right? So these are actually sums. So your text here in this pre-algebra or introductory to algebra stage basically just throws this at you, and I'm not really happy with that, but I'm going to do my best to introduce you to it. And then as you go into the next level of algebra, you're going to see more of this and hopefully have a foundation here. So first of all, let's understand what's an exponent, which I also which I would also like you to probably pause and go look at the rules of exponent. Go do that now. So now that you know what a polynomial is, pause and review the video on the rule of exponents. Okay, I trusted that you did that, but I'll briefly review what an exponent is. So basically, if we have an exponent x to the n, right, x is called our base, and n is called our power or exponent. All right, and you might have seen this before, and just doing a quick recap. So, and I know I've explained to you in the past that the power or exponent of a base, it really tells you how many factors of the base you have. So if I have x squared, it's saying I have 2 factors of x. Also, when I talk about my rules of exponent, I mentioned when in doubt, expand. So you remember we did early in the course when we were expanding variables and expanding whole numbers? Well, here is where that concept could, apply or connect. So x to the square times x cubed is the same if we expand it is 2 factors of x and 3 factors of x, which gives you 5 factors of x, right? If we were to contract this back into an exponential form, it'll be x to the 5. So basically, what did you think happened here? We had an exponential of x squared and times another exponent of x cubed. And then when we broke that down, we ended up with x to the 5th power. So basically, what this rule is really saying is that when bases are similar, and this is a recap because when you looked at the rules of exponents, this was there. So when bases are similar and you are finding their product, which means you're multiplying, right? You add the powers, or add exponents, right? So that was one of the rules of exponent. That was the addition rule, which says x to the n times x to the m is same as saying x to the n plus m. So x squared times x cubed is the same as saying x to the 2 plus 3, which is the same as saying x to the 5th power. Okay? So that's where that rule come in, and I said when in doubt, expand. So if you want to know how many factors of x you have in this product, just expand them as I did here, and you see that you have 5 factors, and that's where that rule came into play. So that's one of the rules you're going to be using at this pre-algebra introductory algebra stage. And another rule there we say, so let's say we have x squared, and that is also raised to another power of 3. So what's my base here? That's correct. My base is x squared. So my base is x squared, and my power is, my exponent is 3 cubed. So it's saying that I have 3 factors of x squared. That's what it's saying. I have 3 factors of x squared. And when I look at my individual expansion exponents, I have 2 factors of x here, times another 2 factors of x times another 2 factors of x. So if I was to add all my factors of x, I have 1, 2, 3, 4, 5. I have 6 factors of x, which I could represent as x to the 6th power. So if we look at this carefully, instead of us going through this whole shebang bang, as I mentioned in rules of exponents, when I explained them, basically, if we times the power, right, we get the same thing. X squared raised to the 3rd power is same as saying x to the 2 times 3, which is x to the 6. 2 times 3 is 6. So that's where that concept came in. So if we have x to the n raised to the m is the same as saying x to the n times m. So therefore, right, x squared cubed is the same as saying x to the 2 times 3, which is x to the 6th power. So these are the 2 rules that you will be using at this pre-algebra stage. You'll be using the addition rule of powers, and you'll be using the multiplication rule of powers. So let's do some examples. Okay, so here we have, and remember, these are applying to factors only. Remember, there's no sums here where those rules are being applied. There are no terms. So here we have x to the 5th times x to the 7th power. So that is x to the 5 plus 7, which is x to the 12th power. Here we have x to the 0 times y square and y cube. So we have no power of x to times x to the 0 by. So this is x to the 0, and that's y to the 2 plus 3, which is x to the 0 times y 5. And one of the rules that I didn't mention in this forum, but it is on the rules of sign, that anything to the 0 power is 1. Any base raised to the 0 power is 1. So that's the 3rd rule. So there's 3 rules for this category. They just slipped it in there. I don't even know if they made reference to it in when they were teaching you how to do it. I'll double check. Don't quote me on that. So this is actually 1. This is actually 1 y to the 5th power. 1 y to the 5th is redundant. So it's really y to the 5th power. Here we have a combination of factors. So all we have to do is look for the common factors and add their powers. And the rules of sign still kicks in, right? So this is negative times a positive. It will be a negative. So we have 1 factor of r, and we have 3 times 2 factors of r. So we have negative 3 times 3 factors of r, because that's 1 plus 2, 3, right? We have 1 factor of s and another factor of s. So we have 2 factors of s. That's s1 plus another s1. Then we have 3 factors of t plus another 1 factor of t. So we have t3 plus 1. We have t to the 4th power. And that's our examples. Over here now, we have powers raised to other powers. So we know we'll be multiplying the exponents. So this is x to the 4th power raised to the 5th power. So there's x to the 4 times 5, which is x to the 20. Right? Here we have 2 factors that are both raised. They are both the bases of this square term. My base here is a cubed b cubed, which is, say, I have 2 powers of a cubed b times a cubed b, right? And again, and then I have, look, see, I have a cubed and another a cubed. So therefore I have a to the 6th. I have 1 power of b and another power of b. So I have b squared. Or I could simply say a to the 3 times 2, right? Which is 6. And b1 times 2, which is b2. See the connection? All right. Because when in doubt, expand. Same apply here. So instead of me, so be very careful. This square power is only applicable to 2ab. That's this is the base This is the base of this, not anything to do with this separately. So we want to work this out first, keeping in the rules of operation, which says operate with exponents, then multiply. So this is actually 2 squared, a squared, b squared, times negative 3a squared b. So 2 squared is actually 4. So let's, if you see that by hindsight, go for it. But I like to work in steps so you could know how the answer came about. And also, if you make a mistake, you could retrack where your error is. And this also helps you in getting extra credits. If you got a problem wrong in the end, and hopefully a reasonable professor see you took several steps to get to your answer, they could trace that you just made an error, and then you could just probably lose a point or two versus getting the entire question wrong. So this is 4 times 3. We multiply common factors, which is 12, negative 12, positive times negative. Now we have 2 factors of a and another 2 factors of a. So we have 4 factors of a. Keeping in the rule when multiplying like bases, add powers. We have 2 factors of b and 1 factor of b. So now we have 3 factors of b. All right, guys. And at this stage, for the pre-algebra, introductory algebra stage, this is all you need to know for polynomials. Unless something else come up, of course, I will be guiding you or providing you with the tools to work these problems out correctly.